The research field of explainable AI, or XAI, is dedicated to understanding and explaining complex AI systems and machine learning models. In recent years, this field has seen the development of many new explanation methods. However, different methods explain different aspects of the models. For instance, SHAP, LIME, counterfactuals, and IL-plots all have different motives and should be used for different explanation purposes. Therefore, it's essential to use an explanation method that fits your needs, rather than always sticking to the most accessible and familiar ones. So, how do you choose the explanation method that best suits your needs? Here, the tool Explego comes in. Explego is a freely available, easy-to-use tool that helps data scientists and the like to choose an explanation method that actually answers the explanation questions they have. The web-based tool consists of an interactive tree diagram where you are guided to an explanation method by answering questions about your explainability needs. If you're wondering where the name Explego comes from, we'll get back to that soon. Now, let's take a look at how Explego can be used in practice. To showcase our tool, let's assume a data scientist at, for example, a real estate agency has used historic data to train a machine learning model that predicts property sale prices based on a series of properties of the home. Assume the model was trained on data spanning several years back, and the data scientist questions the value of some of this older data, which is of poorer quality. So let's see how we can use Explego to find an explanation method that helps identifying the value of these training observations. To get started, you open the web browser and navigate to explego.nr.no. The question we need to answer pop up one after another below here. And the first question is whether we want to explain the whole model or specific predictions. In this case, we wish to explain the whole model, so we click on that. Moving on, the next question is whether we are interested in the features or the training observations. For this explanation question, we are interested in the effect of the training data, and thereby go to the right. This already gives us the suggested explanation method, data bandsaf. This method uses bandsaf values, a game theoretic method like Shapley values, to decompose model performance onto the training observations. In the end node here, we provide a short description and interpretation along with links to software, papers, and other resources explaining the method, and some handy nice-to-know bullet points. Assume the data scientist initially trained a model with a lot of features and now considers removing those that do not contribute much. Once again, we answer whether this explanation question concerns the model as a whole or specific predictions. And once again, we click on the whole model. Now, the next question is, again, whether we are interested in how the features or the training observations impact the model. As we want to measure feature contribution, we click on Features. We then carry on to a slightly deeper question of whether we are interested in the effect of recording the features or changing the values of the observed features. Since we are looking at feature removal, left is the appropriate choice here. The next question is whether we want to consider features one by one or their joint contribution. Whenever we are a bit unsure on what to answer, we can click on the blue text in the question to get examples of practical situations where one should select one over the other. In this case, we want to get the full picture accounting for joint efforts and interactions, and therefore go to the right. We then end up with an explanation method called SAGE. This method is based on Shapley values and decomposes the expected model loss onto its features. As before, brief descriptions, interpretation, links, and nice-to-know notes are provided in the end node. Now, let's consider one last case. A homeowner looking to sell gets estimated price of $430,000, leaving her $20,000 short to fulfill her new housing dream. She therefore wonders what can she do to increase the estimated sale price to $450,000. This time, our explanation questions concerns a specific prediction rather than the model as a whole, so we start by going to the right. This case also concerns features, so we go left here. This case is not about removing features from the model, rather about how changes to the property can increase the estimated price. We therefore go to the right. We're now asked whether we are interested in the prediction itself or some decision or classification based on the prediction. Once again, we can click on the blue text for example-based guidance. Since the homeowner wishes to reach an estimated sale price above $450,000, this case falls into the categorical prediction basket. Finally, we want the explanation to address how she can fulfill her new housing dream. In other words, we want to explain a different decision. For this case, our tool suggests counterfactual explanations. This class of method explains the prediction by providing examples of changes to the features that would result in an estimated price above $450,000. The whole decision tree looks like this. It contains a total of 13 different explanation methods and should cover the majority of explanation use cases for machine learning models based on tabular data. Oh, and the name explego, that combines the word explain with the Greek word explego, where the latter means to make a deliberate choice. We hope the tool will help you do exactly that. As you have seen through these examples, our tool makes it easy to find the right explanation method for users with different needs. Give it a try yourself right here. Happy explaining!